is Hossein, and I'm here to present you.
Good evening, everyone. I hope you are fine. Today we will talk about how to start in electronics engineering from the first step to working in big tech companies. We have a special guest with us, Engineer Hossein Abedini, Senior for Electronics Engineering at Tesla. Go ahead.
Yes, so here I am. Thank you, everyone, for your time to be here with us. I really appreciate the time that you are dedicating. Yeah, my name is Hossein Abedini, right now working as a senior power electronics at Tesla, and I will be presenting like 12 slides, including introduction of myself. And I hope that would be useful for all of you. And if you have any question or comments, I will be here to answer all of the questions and answers. So no limitation for time. I try to keep it free for everyone. So in this presentation, first I have a table of contents that I will start, as I mentioned, with the introduction from myself and the journey that I took from the start to the point that I got here. I will go through some essential key points like IK, IGI model for yourself and also every other subtask and your personality to understand what you want to do. And I will introduce some essential software tools, which will be your digital toolbox to be able to start the tasks and also understand and develop your skills from start to advanced. I will tell the learning path that I took from basic to advanced and what industries are actually needing if you want to take an example and also a pattern for yourself. I will talk a little bit about my mistakes and that they will be your shortcuts and they will help you to not do the same mistake as I did. And I will go through one page about how you can create your brand and introduce yourself and have a professional profile that will make you visible to all of the industries and also recruiters that they will help you to uh, to get your future job if you already don't have and you're trying to change. And I will go through the roadmap and also the goal and the roadmap to get to the global companies and big companies. And also the last slide is something a little bit spiritual and the most important one based on my experience through my professional career. So this is a short introduction of about myself. So I did my bachelor in electronics and telecommunication engineering starting from 2009. On the left side bottom, you see a picture of one of the first projects that I did during my bachelor. It was a GSM GPS tracker that was able to communicate with the GSM module through a SIM card and get the location of the module and send it back to the user. So this was one of the first projects that I did. I tried to do the hardware and also software development of the microcontroller myself, and I think this was one of the key points for me to start to be successful and also understand what I'm good at and what can I be in the future. Then I continued my master in power electronics engineer. The second picture from left side is my master thesis project. It's a three-phase, 3 kilowatts motor drive for synchronous motor. And I did also some other projects like on designing the hardware for some ground robots and also the first domestic engine control unit for a diesel engine in my origin country. And after finishing my bachelor and master in my origin country, Iran, I moved to Italy in 2018 to work as a researcher and also doing my PhD at University of Padua. The right picture, the last or the first picture on the right side is the lab that I was working at University of Padua. I spent 4 years there to finish my PhD, and finally
Can
I
you
moved.
increase your
Yeah,
volume of voice?
yes, I will try.
Okay, thanks.
Just a moment. So I think now is the last that I can do. Is it better or I should
Yes.
speak louder?
Um, I think your voice now is clear.
Okay, perfect. So I will also try to speak a little bit louder for the listeners to understand me easier. So yes, after moving from my country, Iran, to Padua, I spent 4 years there to finish my PhD in power electronics control engineering. and moved to Germany in 2022 in Stuttgart city to start to work for an automotive company which was emerged from Bosch. I worked there as a hardware developer engineer, and then I moved to a bigger company which was called Borg-Warner. It's an automotive supplier from USA that they are specific and they are experts in the supercharger and turbocharger for automotive and working with the customers like Bosch and like other big car companies here in Germany. And at the end, around a year ago, I moved to the Tesla, located in Freiburg, Germany, and right now I'm here as a senior power electronics controller engineer working at Tesla. So this was a short introduction about myself and the career and like the path that I took with a very general overview. And in the next slide, I will talk about very important aspects of understanding yourself and understanding what it can be offered to you from the environment around yourself. So there is this Japanese model called IKIGAI model that it helps a lot also for your personal development, not only in the career. So for me, when I want to make any decisions that I have that I'm a little bit confused and I don't understand what to do, and I want to help myself to make it very clear for me, first of all, I will try to understand what I love to do. So if I'm going to choose a career and a job for my future, I will try to understand what I love to do. And I will also try to understand the things that I'm good to do. So if I'm good, for example, a very general and specific question at running, and I'm good, like I love to run, then that's my passion. So I understand that running is something that I would love to do, and I am also good to do. So to finding your passion is very important. So if you start a career that is not your passion, so you don't love it and you are not good at it, you will damage the team that you are joining, and also you will damage yourself and your motivation. So this is very important for you to understand what you love and also what you're good at. After understanding your passion, you have to understand also what is needed from the world outside and how they can be paid to you. So if you're doing a job that you are good at and you love to do and is needed from the world outside, so you are already sure that you have a good mission, you have a good passion, and if this is going to be paid, that would be a perfect career for you. So this is the model that I'm always using for my personal development. Also the tasks that are not related to the career and I'm a little bit confused, this is the model that I'm using. And I also suggest listeners try to consider this and also to use it for your personal and career development. After understanding this, as we are right now speaking about electronics and also power electronics in this meeting, I prepared a list of tools that they can help you to develop yourself and also understand what you're good at and also understand and learn the trends that are going by joining the community related to the softwares. So as an electronics or power electronics engineer, you always start with the hardware, and the hardware for the hardware you need to design a PCB, and the PCB is like the board that you will be working on, and it will carry out the signals and will hold the components that you have, like a motherboard of the computer. And as you see, the recent years, we have all of at least one digital microcontroller and digital processor on our PCBs. So the software development also is very important right now as a to be a very good power electronics and or electronics engineer. So to enter the domain of digital processing and also digital control, you need to know how to program and develop the software for a microcontroller. And also, as the basics of the electronics engineer, you need to know the PCB and also how signals are routing and moving around and they are connected to each other between different components. And of course, simulation and design tools are the bridge between these two, and you never start a project without doing the analysis and designing and performing the simulation. So if you start a project without doing the simulation and you're just right after jump into the final product, designing a PCB or developing a program, that would be a failure, or that would be a very high cost project for you and with a very low success rate. So I suggest that we take the path from simulation and design, and then after validating everything in the simulation board, we can continue to the PCB design or the hardware design, and we can develop the software for the hardware that we are designing and close the project and have a complete product that is successful. So in this list, I will go through the softwares one by one, and I will try to introduce them to you if you don't know them already. That most of them are softwares that I'm recently also using in my personal development, when I'm off from work. And in this slide, I'm not trying to promote any company. I'm not trying to support or discard any company. This is just my favorite tool, and it's not also related to the Tesla work. I'm not allowed to share exactly what softwares you are using at work, but these are very useful for you guys to be able to understand and also learn for free at home. So the most favorite one to simulate and also understand the transient or frequency behavior of a circuit. For example, if you have a resistor or a capacitor, they are connected to each other and you want to see the behavior of the filter that you are designing, the QSpice is my very favorite tool. It's free, it's super advanced, and it's very recent, really published. It's like the next step for the LTS voice and PS voice. And the difference is that you can support, it can support C++ modules within itself. What does it mean? It means that you have a tool that you can write C code similar to a microcontroller programming, and you can have a simulated digital controller in the environment, and you can also simulate all of your analog components all together and understand to learn how everything works. It's super amazing. It's very easy to use. You can just Google it. There are many tutorials and videos on the YouTube and also their website, and they walk you through them. I didn't bring more slides to go deep into the software, but the goal here was for me to help you to understand the starting point, and later on you can develop based on the basics that we are starting here and giving you the general idea. So QSpice, if you want to do a transient or time like frequency domain analysis, you want to do digital or analog simulations, it's a perfect tool, free, very light. You can try it, install on your laptop and start playing with it and enjoy it. The next advanced simulation tool is the ANSYS. ANSYS is the multi-physics simulator that can be connected to the Altium Designer, which is a PCB design tool. In ANSYS, you can simulate high-frequency electromagnetic components and understand the behavior of your products from the EMC and EMI perspective. You can import the geometry of your PCB. You can see, for example, if you have a CAN bus or a UART and you are communicating with the clock signal with high frequency, you can see the radiations. You can see how your signal will look like in your PCB when it starts and get to the source, get to the load from the source. And it will help a lot to debug the PCB issues after designing the PCB. So it's very expensive, and it's something that usually companies have access to it. But if you don't have access and if you are interested in this area, you can use OpenEMS. OpenEMS is open source. It's not strong as ANSYS, but it's good for many EM simulations and understand and start the basics. The next one is MATLAB and Simulink. So MATLAB and Simulink is a very rich mathematical and data analysis tool, and also including Simulink package, again for transient and time domain simulations. But in MATLAB and Simulink, you cannot import like a spice model from different vendors. Like if you have a op-amp and they provide your spice model, you cannot use it in MATLAB and Simulink. You can use it in ANSYS, you can use it in QSpice, but not in MATLAB and Simulink. But for higher level simulations and designing the control, it's a very good tool. So if you have QSpice already installed, if you have OpenEMS installed, you can complete this package with Octave. Octave is a tool very compatible with the same language that MATLAB does. So if you learn Octave language, you already know MATLAB. And if you don't have the license for the MATLAB to use it, and you know Octave for free on your PC, as you have the capability that when you start a job in a company or at university to start right away with MATLAB, as you already know Octave. They are very close and similar to each other. And the last one is a complete package and it's more advanced compared to the first three that they are essential, and I marked them with the green. It's the Plex simulator, and it's also a multi-physics simulator that gives you the possibility to simulate the thermal behavior and also the electrical behavior of your circuit. And if you don't have again the license, you can go with QUCS software as a replacement for a free alternative to use it. After finishing your simulations, you have to design your PCB, and to design your PCB, you have to start with a schematic. So the schematic will be similar to the schematic that you are using in your simulation tool. And from the schematic, by connecting the footprint of every component that you have, you can start to design, place the component on the real hardware layout, design it, put it in the 3D model, and later on give it to the manufacturer to produce the PCB for you, buy your components, do the soldering, and get your PCB done. So Altium Designer is one of the very advanced tools that can be connected also to the ANSYS. What does it mean that it can be connected to ANSYS? So in Altium Designer, when you design a geometry and you have your PCB done, you can import the result, the output of Altium Designer to ANSYS, do the validation before giving to the production. And if you see any issues related to the magnetic or interfere between the signal, you can
Could you
do a
please could you please zoom in a little so we can see the presentation
yeah,
more clearly?
yeah, sure. How does it look now?
Yes,
So it's good right now, or shall I do it more?
yes, it's amazing.
Okay, perfect. So yes, from the Altium Designer, you can give your PCB design that you have to the ANSYS and do the ping pong there and improve the corner cases and the issues that you will get on your PCB from the hardware. And after finishing everything, you can give it to the manufacturer. We have also the same capability from KiCad, which is a free alternative of the Altium Designer, open source. You can have it on your PC, install it, just try to learn how you can design a PCB, and later on you're ready to join the industry by playing with the KiCad. KiCad also has the same capability. You can connect it with the OpenEMS and give the results of the KiCad to the OpenEMS, and OpenEMS to the EM simulations for you, identify the issues and improve your PCB layout and so on. And the next one is Proteus and Easy EDAs. They are not essential like the first row, Altium Designer and KiCad, but they are also very good tools, but not necessary, as I didn't also mark them with the green. But they are the advantage of the Easy EDA respect to the other one is it's a web-based tool, so you don't need to do the installation. But if you don't have a good internet connection, which I also would prefer to work offline most of the times, I go with the offline tools like KiCad. And if you're going to have a digital microcontroller, you have different options from different companies like ST Microcontroller or Texas Instruments are two brands that are very famous, and they are worldwide providers. Like if you have a microcontroller from Texas Instruments, you can also download their Code Composer Studio. This is the IDE that they also developed to be able to program for the microcontroller that they have. Or if you are going for the ST microcontroller, you can go with the STM CO2Cube IDE. That is a graphical user interface for you to be able to do the registers and also not to get too much deep into the datasheet and also get what you want to do easily done graphically. You can also, but these are advanced tools that they are mainly used in the industries and they are not cheap to start. So if you want to have a board that is supported or produced by Texas Instruments or ST microcontroller, you have to invest a little bit of money. But the free alternative is Arduino IDE. So Arduino is the provider of the hardware that they have very cheap and hobby-friendly tools out there, but you can do some cool projects with them. And also you can use the VS Code, Visual Studio Code for free also installed. Visual Studio Code is a general programming tool that you can connect it with everywhere. So you can do a Python programming there, you can do C programming there, you can do C++ programming there, and you can connect it with different IDEs like QSpice in the beginning. If you have a C++ module, you can connect it to the VS Code and do the C++ coding for your modules there, or you can connect to the Code Composer Studio or STM Cube and do the C control projects that you want to do in VS Code. The advantage of the VS Code is that you can easily use recently published Copilot, which is an AI tool for free. So basically, you have an AI agent in the VS Code that you can use it for free. And to do that, you need to have a GitHub account, which is very easy to do and free. So GitHub, if you already don't know, is a tracking tool that very important for the project management and also understanding what you are doing. For example, if you are today you're writing one line of the code and tomorrow you are changing it, you can track your changes, and if you get to an issue and bug, you can come back and compare with what you have done and so on. So if you have a GitHub account, you can connect it to the Visual Studio Code, use Copilot AI for free, and this will be a university for you already. So you can learn a lot from the AI. You can just ask a question, write me a Python code to do this, or write me a MATLAB code to do that. And if you, for example, write a MATLAB code with AI, you can run the results in Octave, the alternative of the MATLAB, and see the result. Like you can ask, for example, to do a sine function for me and do a plot of the output waveform for me. It will do the coding for you, and what you have to do is just read the code, understand the basic and fundamentals, and plot it in the Octave, for example. If it's a MATLAB code, or it's a Python code, or if it's a C++ code, you can view all of the interfaces, and it has also very rich extensions that it will make the life much easier for you guys as a power electronics or electronics developer. So this is a general overview of the tools that are useful to have. I try to mark the green ones. The green ones, the main focus for me was to provide free tools, because for me to do something at home and to have something to be able to learn more every day and every day, I don't want to pay for a license which is 30,000 per year. For example, MATLAB has a price like this. I prefer to have similar advanced tools that they give me the same possibility and they are free and open source. So I try to highlight the softwares with the green color, and I hope you can also use them in future. So the learning path that I took from start to this point, I think the first 2 years are very common between all of the engineers, and the engineers will start to uh, like deviate from each other and get a little bit more specific from the third to fourth year and go on. So what was very important, and when I look back and I see it was very important and helping me, was the mathematics. So mathematics for me was not knowledge to learn like physics. Mathematics was for me a different language. Like my mother language is not English. I learned English and now I'm able to communicate with all of you. Mathematics was the same for me, the language of engineering, or all of the basic science like physics and chemistry. So if you know mathematics good, you know a new language that you can communicate with science. So fundamentals for me was very important, understanding the mathematics and developing further to understand the digital and analog signal processing. And like this is the next step in the mathematics, and using all of this digital analog signal processing and mathematics to understand how circuit is working in analog domain or digital domain. After closing this part, then it starts to understand how the digital domain can connect to the analog domain. So if you have an analog filter and low pass filter, AC filter, how you can control the voltage of the capacitor with a digital microcontroller. And to start that and play with that, I had to learn basics programming in the C and C++. And still I'm using this even in the high like and industries. C and C++ or something that you never regret if you try to learn as a part of your fundamentals. Another point that helped me a lot was the project that I did, the GSM GPS tracker that I show you in the beginning. So I also suggest you guys to try to get your hands on the work and do your first microcontroller project. Very simple, small PCB. It shouldn't be complicated. Just try to design a PCB, put some capacitors and resistors next to each other, try to turn on an LED, turn off an LED, try to have a cheap microcontroller, try to program it, try to have something in the beginning, and try to get your hands on the work. This will be a huge change when you continue working. You will understand the limitations easier. You will face a lot of issues that later on, when you are doing the study and you are growing yourself further, you understand the connections, and this will help you a lot to be a professional in future. In my case, that I continued my master in power electronics engineering, I continued from the third year to understand power electronics, to get my hands a little bit more advanced in the PCB design for my master project, which was a industrial motor drive. And after that, I got introduced to the control system design engineering and how can I control, for example, a power electronics or a power system, for example, a motor or something like this. And I understood that like it's not simple like turning off and on LED. You have to understand hardware. You have to understand what you want to control, and to do it again, mathematics is your basics. So you can model your plant in the S domain frequency, and you can do the analysis, design your controller, implement on your microcontroller in C and C++ language, and connect everything together. And after finishing the graduation, like my master, I started PhD and I did the research. I got into the advanced simulation and modeling, which ANSYS and more MATLAB was a part of that. And I got involved into industries a little bit more by understanding the requirements, what is necessary for the industries, what we have to pass, what we shouldn't do, what we should do, and stuff like this. And I got a little bit deeper in the research and also leadership and also doing the mentoring of the students at university, like master students, and helping them finalizing the project. So this was the path that I took, and I think it will be very common, maybe a little bit adjustment depending on the person that is working, and yeah, you can adjust it a little bit and also find it related to what you are doing to be able to be successful. While you're trying to take your path and try to complete your IKGI model, we have to understand what is needed from outside and also what is going to be paid. So here I'm trying to build highlight some of the skills that are necessary for you guys to be able to be successful. So technical skills, we already talked a lot, but to close it and to summarize, you have to have again fundamentals, very good fundamentals. For me, mathematics was very important. Having understanding digital and analog processing and understand the math of that was very important. Keeping your hand on the hardware and experience what you're learning. If you learn only theory and you don't try to apply it, that will be forgotten soon and you will not use it in future. So if you put your hands on the hardware and you try to implement what you have learned, that will stay with you more. And you have to be able to do the analysis of the work that you are doing. You have to be a person that is eager to see the problem and solve the problem. Engineering is basically this. So if didn't exist any problem in the industries, we wouldn't be hired by companies. So they are hiring us to solve the problems. So you have to be able to understand the problem and do the analytical analysis and approaches to them and be able to solve them. And also, you have to be good to be in technical documentation. So if you are not able to document what you are doing, your experience will be lost also for yourself. You cannot remember what you have done 2 years ago. If you are good and you are able to document what you are doing, you will be able to remember the details and you will be able to present to the other people. So these are technical skills that you have to have if you want to be successful and join big industries. And also there are some soft skills that also are very important in our daily lives. But if you are strong in them, for sure they will help you a lot when you are joining the industry and big companies. You should be able to communicate. You should be able to ask questions. You should be able to answer questions and like explain clearly. So communication is very important. So this is the most important thing that also will help you to work in a team. If you're not able to do a good communication, if you're trying to be shy and you're keeping yourself shy. So for me, I was a shy person. I had to fight with it and I was able to change it. So if you are a shy person, you can do it. It's not a limitation that I cannot change it. You have to fight with it. You have to be open. You have to try to involve in different teams and you have to practice it while you're at university and while you are doing the internship and workshops around. And you have, so one of the other things that is very important and it can help you a lot is to have a mentorship. So try to find a mentor. Try to have a very good LinkedIn profile that I will explain in coming slides and try to find the people that you can see that they can be your mentor and you would like to continue like them. try to talk to them. There are a lot of people also in Europe and also around the world. I saw that they get to their retirement, they are full of experience, and they really enjoy being in touch with the young people and help them. So me as well, one of them. So if you have any questions, if you have anything to share, if you want just to talk about something, feel free to contact me. I will be always for you there. And also, there are also a lot of other people similar to me. Try to find a mentor. Don't try to do it alone. So be a part of the team and find a mentor. You have to be able to understand the project and also do the time management. So if you have a project that you are doing and working on this, and the time is very important. We cannot finish a project that is needed in 1 year, in 10 years. If you finish a project late, that won't be useful. So you will lose all of the results. So it's very important to be able to break down a big project to smaller subtasks and to be able to do the human resources management for yourself, how much time it will take from myself. So as a single person, I can spend 1 hour per day, for example, on this. That would be in 8 days, one working days, for example, 8 hours. And if I work like this, how much it will take to finish this subtask. So you can do human resources and time management yourself easily by breaking the big projects to small tasks and to be able to estimate the time that you need it. And you have to start it now. If you don't do it now, you will not learn it. And later, when you join a company, you will face issues. And you have to continue to learn always. So electrical engineering, software engineering, and IT, as you can see, especially now with the AI out, is super fast trend and is super fast changing. If you stop learning in 1 year, you have to start again. So please continue learning and never stop. So I did some mistakes that I'm going to share with you here that probably and hopefully it will be something useful for you that you will not repeat it. And when you get a little bit more professional, if you are not already, you will not regret when you're looking back. As I mentioned, don't focus only on the theory. Try to apply what you're learning. Try to do some project, get your hands on the work, and try to understand what you're learning, where it can be applied. So try to challenge your mind and understand the use case of everything that you are learning and you are trying to do. Don't work alone. Try to join a team. Try to start with a friend, try to start in a small team, try to join communities like Discord and LinkedIn groups, try to be active and a part of the team. This also will help you a lot to understand your soft skills and also improve them. I ignored industry trends, so for a period I didn't care what industry is doing, so I was focused on myself and what I would like to do. So I was missing a part of that IKIGAI model. Don't do this. Stay tuned, check the news and see what industries are looking for and what they are planning for the future. What I did worse more than everything was that I didn't do a good documentation. So I started doing documenting my work like when I was finishing my master, which I think it was very late. I had to start from to document everything from scratch, from beginning of my bachelor, every task that I'm doing, that and to keep like a diary of technical achievements for myself. Right now, I'm documenting every day of my work. I'm documenting every hour what I'm doing, and at the end of the day, I'm summarizing my day, and at the end of the week, I'm summarizing my week, and this gives me a very good picture and understanding of what I have done, what was my mistake last week, what can I improve, or if I was good, how can I make it better? Try to avoid difficult tasks. If you have a big task that it can give you disappointment, try to break it down, try to make it smaller, try to share it, and try to finish small subtasks instead of taking a big task that it can take like several years. And then you understand that maybe the path was wrong and you don't have the possibility to adjust yourself. So this is very important and it's related to the documentation that I didn't do. One of my mistakes that I just mentioned. So try to look at yourself as a very high valuable product. All of us as a human being are very valuable and try to make a brand. Like consider a big car company, for example, Maserati, they are a brand. Tesla is a brand. So you are a brand. Try to build your brand. Try to build your brand to be able to introduce yourself to the world around you. Otherwise, you will not be seen. Even if you are a super genius guy, you will not be seen. And if you are not seen, you will not be used. So try to have a very good LinkedIn profile. Try to complete it professionally, because also whatever you put on your LinkedIn profile and you write it down there, that would be used in these days by AI. So AI is looking at your LinkedIn profile, at your GitHub, at your Google Scholar, at your website, and is categorizing you as a talent or not talent person. So if you are good and your friends know, that's perfect. If you are good and your professor know, it's perfect, but it's not enough. So try to have a very good LinkedIn profile. Try to share the codes and stuff that you are doing on the GitHub profile. This is also good because you can share it with other people if it's not something private, and everyone can use what you are doing, and you are somehow contributing and sharing your work. And this will bring the joy more. So you will get more connected to the people and be more successful. If you are at universities and if you are doing a study, try to focus on publishing. Try to uh, focus on the publishing a research paper or a patent. A research paper or a patent is not something that you have to spend extra energy. It's just a good documentation. So if you have a good documentation, try to do it as a patent or publication and showcase the results on the Google Scholar. If you can have a website for yourself, it's good, but it's not necessary. So I bring it here for the sake of completeness. After creating your brand, a perfect LinkedIn profile, a GitHub, a Google Scholar, it's time to introduce your brand to the world outside. So it's advertising. So try to be active on your LinkedIn profile, talk about the ideas that you have, follow the different groups and companies, try to understand what they are doing, try to contribute and give your idea. Join university clubs, other conferences. In conferences, try to connect with the companies and other young people like yourself and also professors. Try to join online communities like forums, Discord, and LinkedIn groups, and try to find an internship to understand what is the difference between university or and real industries. If the internship is not a possibility for you, that's okay. You can join online communities. You can use the softwares for free that I gave you the list. You can develop yourself. You can publish your work. And at a certain point, someone will see your work if you are publishing it and they will reach to you. So what I was doing during my PhD, I was putting all of the publications, a summary and abstract in a very clear and easy understanding with a picture on my LinkedIn profile. And by doing this, a recruiter from Germany found me and they contacted me and I found my first job and I moved from Italy to Germany. So again, this is very important to have a brand. You are the brand and to do the advertising on what you are. What was my roadmap to the big companies like SEG Automotive, Warner, and Tesla. So I've worked for three big companies, as I mentioned. And what was my roadmap? As I mentioned before, strong fundamentals in mathematics and engineering. It was necessary. Without strong fundamentals in mathematics and engineering and understanding what am I doing, it was not possible. Right now, I'm also doing the interview of the candidates who are trying to join Tesla. And this is very important for me to if they have a good fundamental and understanding or not. If they don't have a good fundamental and understanding, that's very easy to see. So you cannot hide it, and that will be a reject. Because if you don't understand what you are doing, that won't be useful. As I mentioned before, it's very important to put your hands on the experience, like try to implement what you're learning, try to understand the use case of what you're learning, try to contribute to the projects and labs, and uh, see how things are working in the real world when you have to deal with to get the product done to the last level. As I mentioned again, do the publications and patents. This is not extra work. This is just a good documentation of your work. As I mentioned, again, documentation is very important of what you are doing. This is very useful for you in a few years. When you look back, you open the documents that you did 3 years ago, you will remember a lot of things and you can just spending one night reading everything and start again. If you don't have documentation, you have to do 1 month of work to remember what you have done. And if you document everything good, you can just summarize them and that will be a paper or a patent. You have to select again based on the ART IKIJI model, which is necessary right now. For me, the case was power electronics and automotive engineering, so I chose this path and I continue my path in these niche areas. Again, try to be a part of a community, try to have a mentor, join groups, be active, show yourself to the people, show that you have ideas. This is very important. And never stop learning again. World is changing super fast. If you stop it for a year, that would be too much. You have to spend a lot of energy to get back on the curve. The last slide is the most important for me. And I think based on my understanding, this is the reason that right now I'm here in this position. So when I was 18, not from a not very rich family in Iran, I was doing my prayers in the morning and I did a deal with God and I said to the God, God, if you help me to become impactful and successful, I will help other people and I will tell everyone that you did it. And I think the reason that here I am talking to you guys also is this. So I think God wants me to be here to share with you, to tell you that effort is from you, but the success is from God. So I also bring some ayah from Surah Al-Imran. If Allah helps you, no one can overcome you and stops you. There are also some other parts from Bible here. Trust in the Lord with all of your heart and be strong. If you do this, you will be successful. The tools that I introduced to you, the softwares that I introduced to you, they are just tools. You have to have faith. You have to be strong and patient and go on. So again, please remember, success is from God and effort is from you. Be persistent, help others as you grow, share with others as you grow, and never stop and go on. So this is the end of presentation. If you guys have any questions, comments, I would be happy. Uh, I don't know, Hiba, if the attendees can talk or it's just comments that I have to read.
Okay, before we end, I have a last question for you. In project management, we often hear about certification like the BMB. So when it comes to electronics engineering, are there any important certifications that you recommended for engineers? And also, do you think being certified is necessary in this field? And in your opinion, which is more important, certification or skills?
I think skills are very important. Without skills, if you have certifications, you cannot pass the interviews. So I would suggest skills are very important, and certification is a good university degree. Good marks from university is a certification. So for my case, when I joined my first company in Germany, which was SEG Automotive emerged from Bosch, they didn't ask also about my university degrees. I was doing my PhD. They didn't ask a degree of my PhD. They just looked how I'm performing the job and how I'm able to overcome the problems. But of course, certification is also necessary. Like when I was moving out from my origin country, Iran, to the Europe, they needed papers. So papers are important, but skills are as well important. So I cannot distinguish with them. Unfortunately, we are living in a world that documentation is important and people look at the certifications. But if you have certification but you don't have a skill, you cannot get to the big companies like Tesla. And there are like several trainings that they can be offered for free. And like if you create an account on the MATLAB website, there are free on-road like courses that you can take, and they will be certified. You can download your certification, and you can also upload your LinkedIn, and people will see that, and that will be useful.
Okay, I didn't think we have question. So
Yes. And if I need to share the presentation with the attendees, how can I do this? So I will continue communicating with you, share the presentation with you, and if someone needs, they can contact you, right?
I will share it with them later.
Yes.
Okay. Thank you very much for your time and for accepting the invitation and for all useful information you shared with us. It was very special and helpful session, and I'm very grateful for all the valuable knowledge and ideas you shared. Your words was very inspiring, and this session was really special for all of us. We are happy to have you with us today. Thank you again for your support and kindness.
Sure, it was my pleasure. Also, as I mentioned to you, I'm doing this for first time for Sudan. So I'm doing this for different countries, but for Sudan first time, it's my real pleasure. I'm really happy to be here. I really enjoyed. I would be glad and grateful to continue doing this further. If some people they need to do, for example, someone needs to understand and learn, for example, one of the software packages that I introduced, we can go a little bit more details. I'm freely open and glad to be sharing with you guys everything that I know. So please feel free to contact me again. I will be happy and glad to be here again.
Thank you very much.
Okay, I wish you all the best and have a nice evening. Bye.
Good night.